Hey everyone, today we're going to talk about shapes of distribution. Kind of look like mountains, but those are shapes of distribution. All right, so as a quick little warm up here, we're just going to start by taking what is called a frequency table and creating what is called a histogram. And so on the left here, we have that frequency table, and a frequency table just is a table that shows the frequency of something happening. In one column, you have the input, and the other column, you have the output. So this frequency table here shows the number of raffle tickets sold by students in your grade. The question is to display the data as a histogram, and a histogram is like a box graph. You have an x-axis and a y-axis, and then you make a box to the height where each one ends up. And so your first step is to draw and label the axes. In this case, the input is your x-axis, so that is the number of tickets sold. And the output is the y-axis, the frequency. So you draw, label those axes, and then draw a bar to represent the frequency of each interval. Once you have your data in a histogram, we can decipher these graphs and decide whether the data is symmetric or skewed distribution. We have skewed left, which means the tail of the graph extends to the left, and most of the data is on the right. So it's key to look at that tail. Symmetric means the data on the right side of the distribution are approximately mirror images of the data on the left. And then skewed right, the tail of the graph extends to the right, and most of the data are on the left. So it is important to look at that tail, and where that tail is how it's skewed, left or right. If the tail's on the left, it's skewed left. Tail's on the right, it's skewed right. So looking at the histogram from the warm-up, this data does not have a tail. Most of the data definitely not perfect, but most of the data falls under a perfect little bell shape that's pretty symmetric. So this data here shows a symmetric distribution. All right, we've got Pearl here to help us out through this. You might hear purling. Okay. So shapes and distribution, note-taking template. I did put the notes here. If it's skewed left, notice, remember the tail. Oh, we brought Pearl in to show the tail. Symmetric, definitely symmetric left and right. And then skewed right would mean that the tail is on the right. And so just a quick example here. Describe how the data are distributed in a symmetric distribution, skewed left and skewed right. Obviously, here we just went over that. Most of the data are on the left. So if most of the data is on the left, or it's kind of opposite, it's going to be skewed right. So I'll type that in. Skewed right. And most of the data is on the right. That means it's skewed left. Left. And the data is evenly distributed, it's going to be symmetric. Oops. All right. And that's it for the first example. So, the reason we decide if your data is symmetric or skewed is a number of things. It tells you a lot about the data. It also tells you which appropriate measure you should use to find um, a true middle of the data. So when the data distribution is symmetric, you would always use the mean to describe the center. So you could use the standard deviation to describe the variation because since it's symmetric, the mean or average would determine the center. But when the data is skewed, you're going to want to use the median to describe the center because notice here the mean is off from the median. So the median or the middle is going to be a better description of that center. And you would use the 5-number summary to describe the variation. Remember, 5-number summary has to do with box and whisker plots. Hint, hint. All right, so the second part of this lesson talked about choosing the appropriate measures, and that was determined based on if the histogram was symmetric or skewed. And so sometimes you have to take that data and create a histogram and then determine, looking at it, what the best measure of center would be. And so in this example, it says you record the number of likes for each of the last 30 photos you posted. The results are shown in the table. So there's 30 numbers here. So that means each photo has the number of likes. So like photo 1 had 74 and then 105. Nice thing about this one here, they actually created the X and Y axes for your histogram. They split it up for you 1 through 20 and then up, number of likes, and then the frequency. So what we're looking for here really is, okay, how many photos had 1 to 20 likes? And you could just look at this data and kind of cross them out and determine it. I found it easier just to put them in a Google Sheet. So I'm going to show that using a Google Sheet, putting these numbers into it. So I went ahead already and put those numbers in a Google Sheet, 30 different numbers. Oh, yeah. Oops, let's undo that. Sorry, they were there. Okay, 74, 105, 98, all the way down. Put all these numbers in. And I'm going to sort them so that I can see just exactly how many of each. And so if you right click here and then do sort sheet, it should sort them in numerical order. So looking at this, and I'll go ahead and move it to the side here. And then I'll move this one. So actually switch spots, right? Don't you think? Move this over here. There we go. All right. So how many likes do we have? How many 1 through 20? So how many photos had 1 through 20 likes? Looks like there's only 2 photos that did. So we will go ahead and draw this. And then 1 through 20, use this pen. I am going to make a histogram box up to 2. All right, next up, where'd it go? There it is. Boop. Okay, what about next? We have 21 through 40. So 21 through 40 looks like there's 1 photo, 2 photos, 3 photos. So 21 through 40, we're going to have 3 photos. So we're going to go all the way up to the 3rd bar. 41 through 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, including the 60. So we have 9 photos for that one. All the way up to 9. It's a good bar graph there. 61 through 80, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, nope, sorry, I counted that wrong. Let's try again. 61 through 80, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that have 61 through 80 likes. Wow, my bar is getting really good, isn't it? 81 through 100 likes. So 81 through 100, so we have 1, 2, 3, 4 of them that do. And then 101 through 120. We have 2. What do you feel is this graph? Is it going to be symmetric or does it have a distinguished tail? I'm looking at this. I would say it is symmetric because if mirror image left and right looks pretty the same. So when the data is symmetric, you use the mean to describe the center and the standard deviation to describe the variation. So the best measure of center is the mean, and the best measure of variation is the standard deviation. Again, graph it, determine the variation or the skewed, and use your chart. Use these little note sheets. They're for you to help you. Don't forget to check out that Big Ideas Math textbook using the link on your homepage, and also remember that we are using the algebra textbook just for this module.